What if I told you that with just 15% change to the training data, we could make a bank's fraud detection system miss 40% more fraudulent transactions?
You serious?
This image shows it's a cat, this one is a dog, the transaction is fraudulent, this one is legitimate. So the AI learns by studying thousands of these labeled examples. Label flipping attack works by corrupting these correct answers. We're not changing the emails or images or transactions themselves. We're changing what the AI thinks the right answer should be. It's like teaching someone math by giving them a textbook where some of the answers in the back are deliberately wrong.
Nice.
Cool. So let's get into the demo. In this demo, we'll be targeting the real-time credit card fraud detection system. The attack vector is positing the training data. Attacker's goal is obviously to make the fraudulent transaction appear legitimate. Business impact is financial losses, penalties from regulatory authorities, and customer trust is gone. Attack complexity is pretty simple, but the thing is that the impact is very devastating. Let's start by setting up our environment, wherein we'll be installing a couple of packages like NumPy, Pandas, and especially the scikit-learn package. Some basic color coding. So we'll be generating our synthetic dataset here, just having 1000 samples, 2 features, and each feature having its center defined here, 2,1 and 6,7. So 2,1, the low value, the low risk, high value, the high risk. That's the policy that is followed here. Cluster spread is 1.5. That's how distant the data points are. Here we'll be building the dataset and we'll be splitting into test and train dataset. I'm using Stratify as yes here so that our dataset is having equal proportion of legitimate and the fraudulent transactions. So you can see here we have 50% legitimate and 50% fraudulent. So there is a class balance, and class 0 is legitimate, class 1 is fraudulent. So let's visualize this. Cool. So we can see that there is actually a separation between the actual legitimate transaction and the fraudulent transaction. Okay, so let's train the model, and here after training the model we can see the accuracy is around 99%. Let's see the decision boundary. Okay, so this is a decision boundary where we see a couple of transaction. The fraudulent transactions are appearing inside the legitimate side, and same thing, I think one transaction is under the fraudulent side. That's fine. So let's try the label flipping attack. So in this case, I'll be taking like 15% of the sample and then flip the value. So here we see that, okay, we can actually flip using this. Let's say in this condition, right? NumPy.where, where we see that, okay, if the condition is 0 and if the value is yes, then flip the value to the other value, right? And we have flipped 15% of the data. So we had 400 training samples, and we have like 15% of that is 105. So we have actually flipped from legitimate to fraudulent 58 samples and fraudulent to legitimate 47 samples. Cool. So let's visualize that. Okay, so this first graph is actually showing the initial data set itself, where we have the segregation of legitimate and fraudulent transaction. And the other right hand side, we see how much of the data is actually poisoned. You can see a couple of red ones. These 2 red ones are actually marked as legitimate. So the X mark which says that it's actually poisoned. Over the legitimate side, we see a couple of them are actually poisoned with the negative verdict. Negative in sense, it's a fraudulent verdict. So class values actually flipped. So let's see the fraudulent analysis. Like let's say that we do the same for different sets, right? 0, 15, 25% and so on. We see that for each change or each poisoning, we see how much sample that has changed. So more the percentage, more number of samples it's actually poisoned, and we can actually see the drop in accuracy. So here 0, we just saw it's 99%, and as we go 10, 20, 30, 40, around 40% we see the gradual drop, and same thing on the error rate also. We can see there's a gradual change in accuracy when the percentage of poisoning is actually more than 40%. Okay, so let's see the decision boundary. So here, obviously, we have seen this 0% initially, and then slowly as we increase the percentage, we can see how the decision boundary is actually changing. So this actually shows that how much, let's say that we change small portion of the data. Here we just took 1000 samples, right? Let's say you're taking, you have around millions of samples. You keep changing some percentage of it, let's say 15 to 20%, or like let's say you were able to change 35%. You see how much the accuracy is actually dropping. So this is the actual impact that's happening just by changing the labels. Next, we'll be looking at the targeted attacks. So previously we saw we were randomly changing the values, right? So here we'll be flipping the target itself, the target class itself. So here you're saying that, okay, 50% of the data of this class, you actually flip it to the other. Let's say from 0 to flip it to 1, and 1 you flip it to 0, right? That's what is happening. So we are just concentrating on one target here. And let's visualize. So here we are actually making fraudulent transaction appear legitimate. So that's what you see here. Most of the reds have turned green. So what we have demonstrated here is, let's say this label flipping attack is the simplest attack which cannot be noticed. Why I'm saying it cannot be noticed is in a machine learning pipeline, we keep adding this data to our data set, right? Keep building the data set as and when we get more information. Let's say that there was some attacker or someone within the company itself got access to the data set and have flipped a couple of data set, right? I mean, technically we could see the change happening using some statistical methods, but let's say that we are not aware of it and we just took the data, built the model, and then the model is having some impact, right? This small data attack shows that how much we need to make sure our cybersecurity practices within the company is actually made sense, right? How much we have actually followed the process and how are we actually monitoring each and every access of every individual within the company. Let's say not within the company, probably as some attacker who has actually gained access to a system, probably he just goes to the S3 bucket or our data lake and make some changes to the data set, right? Who knows? So we should make sure that we are actually monitoring our data sets. With this video, I'm just showing how label flipping attack can be so devastating, even though it is very simple. So probably in the next video, we'll see more AI-based AI data attacks, how the vulnerabilities are added to the model itself, and when you execute the model, it's actually affecting the system. Do subscribe, and in the other videos, we'll be seeing how different data attacks are seen within the AI space. Thanks for watching. I'll see you in the next video.